All right. Good morning, class. Told you I wasn't going to be here today in person, but here I am for you on video. Let's get to work. Please get out your books, and we're going to begin working on Unit 1-1. Today I'm going to teach you how to read and highlight a section. You should be getting out your books, and I want you to go ahead and turn to page 3. You got table contents on page 2. On page 3, and then how to use the book on page 2. Okay, I'm going to zoom in here, and we're going to get to work in just a second. Again, page 4, how to use the book. If you guys will read along as I read it out loud here. How to use the book. The two primary purposes of this book are to be a resource for understanding and a single place for homework assignments. As a resource, you should read the sections in the book that you have a hard time understanding in class. Time out. I'm right here. And I want you to know that I want you to do this reading and highlighting before we have the class. There's a big difference in coming to class prepared and have at least a little bit of an idea by reading a section before you get in here, or listening or hearing something for the first time. I really believe it helps your understanding if you read and highlight sections before we go over them. I don't expect you to learn everything when you read and highlight, but I do expect you to read and highlight before we have instruction. It'll really, really help you. Okay, so moving on in my reading. This book won't replace the instruction that you receive from me, but it should supplement that instruction. That means it should help you understand better if you actually read through the examples and think about what's being said. This book is also a place for homework assignments. The book puts all the homework directly after the explanation of each section. Since you can write in this book directly, you are welcome to do your homework right in this book if you have room to show your work. Let me be specific here. You must show your work. In every section, in all the problems, show your work. You'll probably end up using a separate sheet of paper to do homework on concepts like solving equations, but most units you'll have enough room. Sometimes if our work happens to be really big, you may have to use extra sheets of paper. And I'll tell you, and I'll show you again next week, that I'm going to want you to put that work and those problems in your 3-ring binder in the section. So you can always go back and look and find stuff easily. Okay, moving on to the next paragraph. Included as a homework assignment are unit pre-tests. These pre-tests should be completed at the start of each unit so that I can really zero in on what specific skills you'll need help with and what skills you already know. Some of the things that we do, you will have already mastered. You guys had a great teacher last year, and every year here at Indian Valley, for that matter. So I know there's going to be a lot of things that we're going to do that you've already done a good bit. After that, you should work on correcting the pretest, blah, 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 which acts like a study guide for the post-test and the end of unit test. What you're going to learn as we go through is the pretest, and the review and the test are almost identical. Same problems, different numbers. So, and they'll be exactly the same as the homeworks as well. Please take care of this book. Since it's going to be in a binder, reminder, I told you to get one of those heavy-duty binders. So I hope that you have done that, or at least do that this weekend. We want you to have a heavy-duty binder so that this book's going to take a beating. You're going to have it out every day. This book is yours and only yours. It will not be passed on to students next year. However, if you lose this book, I'm not going to ask for you to pay to replace it, because you're also going to have a digital copy online, so you can see every section and you can just reprint it out if you happen to lose it. Please treat this book with respect. Also, by the way, this book was designed by teachers, and along the way, if you notice any errors, please make sure I know so that we can correct those errors for next year's students. If you need help, to make this book better and better. We need help to make this book better and better. So thank you in advance. I just want to make sure we took the time to read that so you guys realize what's going on here with this book. All right. Moving on down, this is the 6 sections in Unit 1. We're going to be talking about functions, defining functions. We're going to tell you what functions are. We're going to graph functions. We're going to find rate of change, initial values, and other function qualities. We're going to contextualize, and we're going to talk about sketching piecewise functions. So that's what we're doing in this first unit. Here's the pretest. You can skip over that right now. We're not going to do that at this time. We'll do that sometime next week when I'm there with you and you get a better idea of what's going on. So you should be on, what are we, page 8, I believe? Page 10, sorry, page 10. And we are defining functions. What we're going to do here is we're going to read and we're going to highlight. I actually have a highlight function available to me here, so I'm going to show you what I mean by read and highlight. All right, so read and highlight means we're going to read a section and then we're going to highlight the stuff that we think is important. So let's start by reading this first section. Functions govern many interactions in our society today. Whether buying a cup of coffee at a local shop or playing a video game, we are using a function in some fashion. The only thing I'd say there is we are using a function in some fashion. And that's not a real big one. It hasn't even started to tell us what a function is, but that first 2-sentence paragraph is just saying, hey, functions happen all the time. Second one, a function is a rule or relationship between two quantities, often referred to as the input and output, such that for every input, there's exactly one output. If we input a specific value into the function, we get a specific output as an answer. We won't get the possibility of 2 answers, or else it wouldn't be a function. The most common example of a function is the equation such as y equals 2x plus 3. Now let's stop right there and let's look into this. Obviously, a function is already highlighted, so that's something that's important. Well, what is a function? It's a rule or relationship between two quantities. Okay, well, what's the rule? Well, it goes right in and says it's often referred to as input and output, such that for every input, there's exactly one output. What's important there? For every input, there's exactly one output. So what is a function? It's a rule. For every input, there's exactly one output. That's something you're going to want to understand. That's the part that I'll be teaching later next week. But now that you've seen just the important stuff and you get rid of all the clutter, sometimes it makes a little bit more sense. So if we input a specific value in the function, we'll get a specific out, but a function is a relationship or rule between two quantities, input and output. For every input, there's exactly one output. Well, that makes sense. And that's what we're trying to do. Get rid of the fluff and find the important stuff in a paragraph. Okay? So I'm going to keep going. So we have this equation, y equals 2x plus 3. That's the one that we're looking at right now. In this case, x is the input. So, I'm not really highlighting here, but this is the input. The x is the input. It's what it just told me right here. X is the input. Y is the output. So y is the output. If we substitute a value for x, say x equals 3, then we get an answer for y, namely y is 9. So he's saying if you put 3 in there, what's 2 times 3? That's 6. 6 plus 3 is 9. So if they put in 3 for x, they'll get 9 as the output. Oh, okay. Notice that every time the input is x equals 3, you get an output of y equals 9. Since we always only get a single output for any value we input, this is a true function. Okay. Why? Why is it a function? Because each input, let's go way back up here. Why is this a true function? Because each input has exactly one output. Isn't that interesting? So I hope that you're starting to understand what I mean by read and highlight. Take your time, read a section, read a chapter, it's not a chapter, but a paragraph, and decide what's important. And not every paragraph is going to have information in it. Sometimes, like I believe the next one, I haven't read it yet, but I believe the next one is just going to be an example. But let's read it. An example of an equation that is not a function would be y squared equals x. Notice that if we input a 4 for x, then y equals 2 could be an output, or y equals negative 2 could be an output. Therefore, this is not a true function unless we make the function y equals the square root of x, where there could only be one principal or positive square root. I think that's kind of important. I don't know what that means, principal or positive square root. So I might want to highlight that. Or you know what? Maybe since it doesn't make any sense to me, I might want to highlight it in a different color. Because then when I come back to class, I can ask Coach Herman, hey, what does principal or positive square root mean? If that's something you don't understand, maybe it's something you could highlight in a different color so you know already that we have a question. And maybe it's a fact of, this whole thing here, I didn't really understand what that's talking about. So maybe I want to put a question mark so I make sure that that's explained in class. So we start to get what we mean when we say read and highlight. Let's move on to the next paragraph, function notation. Functions represented by equations have different notation. We are used to an equation that looks like this. It looks like y equals 2x plus 3. We've seen those forever. Y equals 2x plus 3, y equals x plus 7, so on and so forth. However, from this point forward, function equations will be written as this. What's the difference between those two things? See, sometimes when you're reading and highlighting, you read something and say, all right, well, it says these two are the same, and it's no longer going to look like this one, but it's now going to look like this one. Gee, I wonder why. So I'm just going to take a second and look. What's different? That's right. This one has a y, and this one has an f of x. All right, let's read on and see what's important. We would say that f is a function of x, that if you input x, you will output 2x plus 3. The advantage of this notation is that we can clearly know what our input and our output are. For example, we might use the function h of t equals negative 16 t squared plus 48t to represent the height of a ball thrown in the air over time. We would say that the height of the ball, h, is a function of the time since we have thrown it in the air, t. So this second paragraph here is giving me examples. Am I struggling with that? Like as I read it, am I not understanding what is said? And if that's the case, I might want to again put a little something there. Hey, I need to remember to tell Coach Herman I don't understand that. Or maybe if you're starting to understand that the only difference in function notation is instead of a y, we're going to write an f of x, and that's called function notation. And JJ's back here making some bacon, and I'm telling you right now, it smells like heaven in here. But can you hear that crackling and popping? Oh, it's heaven. I hope you're making some bacon for me. All right, back to work. So here we are. Let's move on to the next page. All right, the next section talks about evaluating a function means to figure out what the output is when given a specific input. I think that's important. So, evaluating a function means to figure out what the output is when given a specific function. That's what evaluating the function means. Let's look at the following functions that show the total cost of amusement park C, depending on the number of tickets T to ride the rides. So we do the function of T, or C of T, that's how we say that, C of T, equals 2T plus 3. We can evaluate the function for T equals 5, or C of 5. Now you see this? This and this are the same thing, okay? Now you're reading this. I wouldn't be there with you to explain it, but the next day in class, I would be going over my lesson, and I'm just going to give you an example here. I would talk about in my lesson, I'm going to go to black pen here, and I would remind you that, hey, C of T equals 2T plus 3. That's a plus sign, and that's a T. Sorry if they look the same. Okay, that's the same as Y equals 2T plus 3. See how this function, that's function notation instead of a Y. That's not going to be a big deal for us, okay? We're going to learn that really quick, and we're going to be okay with it. And you remember way back when you used to get things like X plus 3, and somebody said, hey, what would it be if X equals 5? So you would take that 5, and you would plug it in for the X, and you would say, hey, well, X plus 3 is 8. You did that. You've been on that since, like, I don't know, what, 5th grade, 4th grade? So you've been doing the same problem. This problem's no different. Here they're just saying, hey, what is C of 5? This is function notation. They're saying, hey, what if we input 5? Well, we'd just put that 5 in for the T. So we'd have 2 times 5 plus 3. And that's what I would be teaching you in class. And I'm sorry, that's really ugly handwriting. I'll get better as we go. But that's what I would be teaching in class. So having you have already read this, and hopefully you would be able to see that same thing. Well, here, right, C of 5 equals 2 times 5. So they put the 5 in and 2 times 5 plus 3. Well, 2 times 5 is 10. 10 plus 3 is 13. So our output is C of 5 equals 13, meaning the cost to buy 5 tickets is $13. So let's evaluate the same function for 10 tickets. Notice how they put this 10 in. So we're going to do the function with an input of 10. So 2 times 10 is 20, plus 3 is 23. Oh, so you just getting the opportunity to read these. Now, notice how long I took to break down and talk about those things. Obviously, you're not going to have to take that much time, but if you can just follow the math that's happening, that they show you step by step, they can help you understand, okay, all I'm going to do is substitute the stuff in like I did way back then. No big deal. And you know what? If as you're doing it, you can write things like this, that's fine. Or when I'm going back and I'm having the lesson, I'm not always doing these same problems or same examples, but you may want to write some of the things that I'll teach you during class in these notes or on the book as well. So our output this time for C of 10 equals 23, meaning the cost to buy 10 tickets is $23. I think a lot of times we forget that math is real world. I mean, there's no subject that's more real world than mathematics. Okay, let's move on. Now we're going to talk about the domain of the function. What is the domain of a function? Let's read. The set of all possible inputs is called the domain of the function. Well, that's pretty straightforward, and that looks important to me. Let me highlight. The set of all possible inputs is called a domain. I highlighted that whole thing. It makes sense. I might have wanted to just highlight, I don't know, a little portion of it, like the set of all possible inputs. All inputs is called a domain. Okay, but the set of all possible. We'll talk about that more as we go. So for f of x equals 2x plus 3, the domain is all real numbers. Any number we want could be input into the function. One way we can write the set notation is as follows. Domain equals the set of all numbers from negative infinity to infinity. That's what that little sideways 8 means. This means that the domain of the function is any number between negative infinity and infinity. So we can put any number we want for x. However, in the context of the carnival, like we were talking about the carnival above in the previous problem, in that context, what does context mean? Anybody? What does context mean? Come on, somebody knows what context means. Really? They do. That's right. Context means when you take a real world situation. Okay? Context is a real world situation. And you know what? If you come across a word and you don't know what it is, man, you better highlight it and look it up. So if we think about the real world situation of the carnival that we've described above, it would only make sense to think of the domain as from 0 to infinity, since we can't buy a negative number of tickets. Notice the bracket here. Notice the bracket here instead of the parenthesis that is there. The bracket means that it can equal that number. Oh, I think that's important. The bracket means it can equal that number. When we use the parentheses, we mean that it cannot actually equal the number. Parentheses cannot equal the number. Bracket, it can. And I will tell you right now, infinity will always have a parenthesis. This bracket, you can sell 0 tickets to the carnival. Get out of my snack, boy. I am recording. My son just come and try to take a bite of my snack. All right. Because it's 10 o'clock at night and I'm doing this video for you guys. Hope that you appreciate it. We're 22 minutes in. I'm almost done. Not really. So if we... Now he's choking. So if we can input 0 and above, greater than or equal to 0, we use the domain from 0 to infinity. But if we can only input numbers strictly greater than 0, like if you can't put in a 0, then use the domain from 0 to infinity with a parenthesis instead of a bracket. So I hope that you see the difference there. And again, that's information I'm going to be teaching you in class. But if you can grab that or at least have a little bit of idea what that means when you come to class, it's going to make your learning so much better. Moving on to the next paragraph. Some functions will have limited domains or ranges. What? What's a range? Well, we haven't told you yet. We'll tell you that in a minute. For example, in the function f of x equals the square root of x plus 5, we can only have input that is greater than or equal to negative 5 because we can't take the square root of a negative number. This means the domain would be written like this. Domain is from negative 5, non-inclusive because there's a bracket. I'm sorry, inclusive because there's a bracket, to infinity. So at this point, man, I'm telling you, if you're not understanding that, again, I would make, let me go that in red. I would make sure I put a star or a parenthesis right there if that doesn't make any sense to me. So I'd make sure that I can have Coach Herman explain that for me better. Okay, if I'm starting to get lost. And that'll happen sometimes in your reading, and that's okay. What this is really saying here, and what I would explain to you in class is what this is saying is, hey, if let's say I put 6 in for that x. So let's say I did f of 6? Well, that would mean what's the square root? I'm sorry, not 6, negative 6. Sorry, negative 6, not 6. So if I put a negative 6 in there, that would be what's the square root of negative 6 plus 5? Well, negative 6 plus 5 is negative 1. So what's the square root of negative 1? In other words, what number times itself gets me a negative 1? Well, there's not one. So that's not possible. So in any number that's negative 7 or negative 8 or negative 9, any number that's lower than negative 5 would also give me a negative number, and I can't take the square root of the negative number. And that's what this is saying for us right there. So I would explain that to you when we got back to class, but sometimes you can't grasp that stuff when you're reading, and that's okay. So if that's the case, put yourself a question mark there so you can ask me when we get back to class. Here's another example of limited domain would be the function of f of x equals 100 divided by x. Hey, a fraction bar is a division symbol, so don't forget about that. This is a fraction, but remember, all fractions are division problems. Fractions are your friends, not food. So, which has a domain of any number except 0? Why? Because we can't divide by 0. So, we might write out by saying the domain is any number other than 0. We might write that this way. D is not equal to 0. Note that this is not in set notation, but rather as an inequality, and that's okay. There's nothing wrong with using the most efficient method to communicate. Look at that. There's that big word, communicate, the domain. So what is domain? I want to go back and look here. What is domain? That's something I want to make sure you pick up here. Domain is the input. Domain is all the possible inputs. Okay? If you only grasp that, out of all that reading, if you only understand that domain is all the possible inputs, man, you've learned something already, and that would be good. Now they're going to talk about range. Well, before we even get into that, let's think for a second. If domain's all the possible inputs, and we're talking about functions that have inputs and outputs, what do you think range is? Let's see. Similar to domain, all of the outputs we could possibly get are called the range. Yeah, there it is. All the outputs are called the range. More precisely, the range is a set of all possible outputs for a function. So all possible outputs for a function. That looks important, so I'm going to highlight it. The range of the function f of x equals 2x plus 3 is all real numbers. This means that the output, or f of x value, or the y value, could be any number, and would write the range of the function as range equals negative infinity to positive infinity. Again, note the parentheses there. That means it can't include an infinity. Infinity will always have a parenthesis. Consider the function f of x equals x squared minus 2. Notice that no matter what value we plug in for x, we always have an output, a number greater than or equal to negative 2. Why is that? Well, when you square a number, doesn't matter what it is, you're going to get a positive number. Like, for example, 2 squared, or 2 times 2 is 4. 3 squared, or 3 times 3 is 9, right? Well, what's negative 2 squared? Negative 2 times negative 2 is positive 4. Negative 3 times negative 3 is a positive 9. So anytime that we square something, we can't get a negative number. So our range, our output's always going to be bigger than negative 2. Why bigger than negative 2? Well, you'll understand that as we get better. But it's going to be whatever that constant is. Okay. Therefore, we would write the range as from negative 2 to infinity. A lot of times it's easier to see the domain and range from a graph. Hey, that's important. Let's consider the few examples. Remember, okay, what is domain? We've already said. Domain is the input? Or what was the value? What was the variable we used for the inputs? Anybody? Anybody? Yeah, that's right. It was X. And what was the range? That's right. It's the outputs. What was the variable? Well, it was f of x, or we used that to replace y. That's right, y. So here, this is the domain, and this is the range. The y is the range. So it's a little bit easier to see it on a graph. Okay, so let's read below here. Domain of this first one can be any number because the graph continues forever, both left and right. So the domain can be either. And then again, the range, any output because it continues forever in both directions, up and down. So the domain is negative infinity to positive infinity, and the range is negative infinity to positive infinity. But let's look at this one, this middle one. Notice that this thing stops right there, and then it goes forever this way. So if we think about the range, this direction, the domain or the inputs must be greater than or equal to -5 because the graph continues forever to the right, starting at -5. So the domain will be from -5 to infinity. The range, rid of those now. Now the range is up and down. Let's go with blue. So the range starts here, and this thing's going forever. It's going up forever. So it starts at 0 and goes up. So the range is all the outputs will be greater than or equal to 0 because the graph continues forever up. So that's all important, and so on and so forth. And I can look at the next one. Well, this one goes everywhere domain except that in the middle. And here it goes forever in both directions except for the middle. So domain is not equal to 0 and the range is not equal to 0. So I think I'm starting to get this domain and range. Domain and range is the input and output. I hope that you're starting to grasp the idea of what I mean by reading highlight. I've already done more reading and highlighting for you than I did for my students last year. So I hope that you're starting to understand it. And I've also thrown some of those ideas and things that I would be teaching you when I am in class. There's still one more page of notes, and I want you to read and highlight that section yourself. So I hope that when we come to class on Monday, you'll have a little bit of an idea of is it a function and how do you determine what a function is as I throw some at you. So again, I apologize for not being in class today, but I hope this was helpful for you as to how to read and highlight. There we go. To read and highlight a section. And I hope you had a great day. Ms. Stafford, thank you very much for being here for me. And y'all have a great weekend. We'll see you Monday.